How you doing, guys? Glad you could come back. This is a second in a series of videos on how to set up a tapered roller bearing assembly. In this particular video, I'm going to go through the math required for selecting the required shim that'll go between the two bearings. In this particular assembly, you're going to use, this is, again, a generic assembly. This could be a pinion shaft, could be a transmission shaft. I'm not sure what it is, but it doesn't really matter. But you have two opposing tapered roller bearings. So this would be the roller bearing on the top, and then you'd have another tapered roller bearing on the bottom, and then obviously in between each one of them you'd have a race. So the idea is both of these bearings are going to effectively affect each other. So if this bearing was to fail, you'd obviously replace the race and the bearing assembly, but we recommend replacing both sides. So this bearing in that race assembly and this bearing, this race assembly would both be replaced. And the reason for that is, again, the micro finish on the rollers is only so thick. So if you were to preload this bearing assembly again, you could burn through the micro finish on the used bearing and actually cause some damage to that used bearing down the road. So typically in this assembly, both bearings would be replaced. But again, that's just something you need to factor in. Where I see a lot of this happening in the field is guys will set up a differential. They may get a new ring and pinion set, put the new ring and pinion set in, and use all their old bearings, and then try to set up these assemblies with the old bearings. You use the old shims, and again, they were always having problems. And if nothing else, they've actually reduced the length of the time that they can run that assembly. So again, always a good idea to replace the bearings. Bearings themselves, cost-effective wise, your labor is worth way more than these bearings. So if you're reusing a $12 bearing in an assembly, it really doesn't make sense. Now some of them can be a little bit more than that, but again, some of them are surprisingly cheap. So kind of keep that in mind. Again, a very generic setup. In this particular case, we have a shim that sets between the two bearings. Now, a lot of people ask me, why do I need a shim? Why can't we just put a standard numbered size shim in there? Why do I have to have a selectable shim? And again, that's due to what we talked already. It's called stack tolerance. Over the manufacturing process of the bearing, the race, the shafts, the case, this entire assembly, if everything is factored out with a plus or minus 2 or 3 10,000ths of an inch, over time it could be thousandths of an inch total in the assembly that can vary. So in that case, we make up the adjustment with this, make up the stack tolerance loss with the shim, whether we go thicker or thinner in the assembly. Okay, so basically what we're going to do is try to decide what size shim to use. Now, in the field, what typically happens in the field is technicians will go ahead and try to reuse the old shim. They'll measure the rotational torque, measure the amount of preload. If it's okay, they're golden. They just go ahead and they continue on. If it's not, then they got to make a call. Am I going to go thicker or thinner with the shim? In this case, if this shim, if this assembly is too tight, I would put a thicker shim in here, because what it's doing is pushing the bearings away from each other, okay? Because the shim is actually on the shaft, goes over the shaft, and it's pushing the bearings in opposite direction. So the thicker the shim in this assembly, the looser the assembly. The thinner the shim, these two bearings can come closer together, it tightens the assembly. So keep that in mind. That's what you got to look at in your assembly. What does the shim do? Does a thicker shim tighten it or loosen it? In this particular case, putting a thicker shim actually loosens the assembly. Thinner shim tightens the assembly. Okay, that's the first thing you need to figure out. Then what you're going to do is you want to select the largest shim available. So go to your parts list. There may be 20 shims available. Grab the thickest shim available, one that's going to create the maximum amount of end play. So in this particular case, I'm going to select the biggest shim. To keep the math correct, I'm just going to make it real easy to understand. We're going to start with 150 thousandths gauging shim. That's what I'm going to install. Once you put that in, you'll notice your assembly is very loose, and that's what you're really looking for. You want to establish an end play that can be measured with a dial indicator. So I'm going to mount my dial indicator up, and I'm going to very accurately measure the end play of that overall assembly. So I'm going to come up with an assembly. Now, when I say accurately, you want to take this several times and get a consistent reading every time. Literally, you want to push down, seat the rollers, turn it back left and right, back and forth till it's your lowest available reading, then push up, pull it up, rock it back and forth, get your highest available reading in the upside, and the difference between the two, whatever the value, whatever the movement up and down will be your end play. So let's just in case, or just for this example, let's say we measure 10 thousandths end play. So if your gauging shim is 150 thousandths of an inch and you have a end play, so your gauging shim is 150 and you have an end play of 10 thousandths of an inch, what that means is if you subtract those, you get 140 thousandths. If you were to take the assembly apart and put 140 thousand shim in there, you will have no readable end play and you will have no turning torque. You will have no preload, okay? It's called zero end play, zero preload. Zero end play, zero preload. From this number, this is an important number, I can put in a preload. In this particular assembly, let's say the manufacturer says, I want to see you preload each one of these bearings by 2 thousandths of an inch, okay? So there may be a specification in the service manual, the Timken, or somebody will give you a specification for each one of those bearings of setting those bearings to 2 thousandths crush. In that particular case, we're going to add them up, so it's going to be 4 thousandths. Okay? 6 becomes 3. Okay, 136. If I did my math right, I've just put in, again, you're subtracting. We're subtracting. Subtract 10 will give you 140, 0 end play, 0 preload. I want to subtract another 4 thousandths from this. Subtracting 4 thousandths, this is going to be your preload. Okay, preload. Pull your preload out of there. That's going to give you a proper shim installation of 136. Go to parts, order 136,000 shim, install the 136. Now, we're not done yet. Once we install the 136, then we're going to take the dial indicator off and we're going to put a tool on here called a torqueometer. I'm going to rotate this assembly. I want to turn these bearings. I want to rotate these bearings and see how much resistance or rotation I have. That will be given to you in inch pounds, okay? Okay. It may be 12 to 15 inch pounds of turning torque. So you're going to go ahead and turn that assembly and sense the resistance or rotation. You're going to use what they call a torqueometer. If you don't have a torqueometer, you're going to use a small dial torque wrench, but you're going to measure the resistance or rotation. You're going to feel those bearings actually crush. You're going to actually feel those things as you rotate. It's going to be tightened. At that point, you know you've set it up correctly. If we're not at this 12 to 15 inch pounds, if we're too low, we want to go with a little thinner shim to tighten it up. If we're too high, maybe you're 17, 18, 20, you're going to go a little thicker. And what it'll do is it'll push the bearings away from each other and loosen this assembly up. But that's an easy, straightforward way of doing a basic shim selection. The only difference in this assembly would be down here, okay, with your, what are you doing? Are you subtracting or are you adding, depending on where the shim's located? If your shim is located in such a fashion where actually making the shim thicker pushes the race into the roller, then in that particular case, you're going to add to these, not subtract. So again, you need to look at the assembly. Now, again, if you've never done this before, this is a very simple way of doing it. Again, a lot of technicians will start with the old shim, measure it to see what it looks like. If it's great, they leave it. If it's not, they just start swagging. They just start adding shims, taking shims away. They order a bunch of parts. It does increase the complexity a little bit, the time. This particular one will get you to the right assembly fastest, and that's basically how you set up a tapered roller bearing with a fixed shim. Again, this is just a generic example, but again, hopefully this will help you. So, all right, thanks.